Hello everyone, I am Dr. Emre Süren. This is Lab 8. We will study random suffix search for prompt injection. So let's get started. The example you see on my screen is an example for random suffix search to enhance prompt injection attack. The green part is system message, as you see. Then we have our task, data markers, instruction block. We start with jailbreak. Then we have our instructions, suffixes, and we have our mutation part. Here we call it more specifically random suffix search. As you see, it is pretty much gibberish text, right? So what does random search means? As you see, they are gibberish strings. They are pretty much meaningless words for human understanding. What we are expecting here, previous statements are logical for human understanding. As large language models understand human language, it is easy for an LLM to understand it. But then we have gibberish strings, which is just to confuse large language model or just take its attention to these words, meanwhile bypass security protections for the previous statements, which are malicious. Once more, random suffix search, this payload mutation part, this text is not malicious. It is just to confuse, falsify the model. Take its attention to this point, spend more processing here, and forget about previous statements. I can simplify in that way. Let's go and see one example. Here is our prompt injection playground codebase. You see Lab8 random suffix search attack. Then we will start with the first stage, which is generating the dataset, right? Here we are reusing the dataset we generated in Lab4. Actually, we have been using this dataset since Lab4. That's why I will pick the file name, the generated file name from the previous exercise. Copy, scroll down, and switching to second stage, which is performing the attack. Here, Spikee quite test, which allows us to perform our prompt injection attack. Second, switches, dataset, we provide our dataset. I paste the file name that I have copied from the previous lab. Then I configure our target. As I execute local models on Ollama, I configure my Ollama API, and I will select Gemma 3 latest model from Google as a target. Then it is enough for our tool Spikee to say the attack is random suffix. As you remember, random suffix search will generate random strings and append right after prompt injection. It is inside the prompt injection block before closing the data markers. As this is random payload, we can try different iterations. Here we will select 3 because we want to keep it short. Normally, depending on mutation attack, researchers suggest 15, 30, 50, this number of mutations. No auto resume, we are not gonna resume it. We are not going to slow down. Now we are ready to start. Now I'm going to pause it It's almost 15 minutes. Now let's get started. But first we need to find the file that we have the results. Exactly the same files. Now what we are going to look for, first we will look at attack name, right? Attack name, random suffix search. We will look at this. Then we will also take a look success, right? It's also in the beginning of payload. Success false. Let's go true. We don't have successful attempts, but we will still one attack. Random suffix search. We have many. I will take this example, copy, manual analysis, clean this file, paste, format document, then view, word wrap. Here is our payload. This part is random suffix. It says different bleach unknown patent official option shared. Some words, but it is not meaningful statement. We are expecting LLM to spend time to understand, to reason about it. Meanwhile, this malicious phrase will pass. When it comes to response, we find the URL address, but test is not encoded with base 64. That's why we cannot find this signature in the response. That's why success is false. The response, pretty much LLM followed our instruction, malicious instruction, but the final stage is encoding to base 64. So far, our experience during 8 lab exercises, Gemini can't or doesn't encode the text with base 64, but when it comes to Q1 model, Q1 coder model does. Now let's switch to final stage, which is analyzing the results. To do that, we need to copy the file name, results file name, paste it, Spikee quite results analyze and result file name, run it, no file name. In that case, I will copy full file name. Yes, the file name is different. Now we have 296 unique entries. We have random suffix search attack, and our success rate is 0% for Gemini. All right, as an homework, what we do, we will try other models like QN. We will not stop execution of the attack, but let it go, complete these iterations. We will increase attack iterations to higher numbers like 15, 30. These are the settings that we can employ to find vulnerabilities for random suffix search attack. That's all for this lab. I am Dr. Emre Süren.